Now we have to solve this question, and in this question we have to find voltage VPQ, or we can say that we have to find potential difference between node P and node Q. Now we will solve this question by two methods. First we will try to solve this question by nodal analysis, then we will try to solve this question by using simple KVL and KCL equations. So the purpose of using two methods is to clear the basic application of network concept in a circuit. Okay, so here you will see how we use the directions of various currents and how we use the polarity of voltages. Okay, so it will clear your many concepts. Okay, so first we will try to solve this question by using nodal analysis. So here we know that VPQ means VP minus VQ. Okay, now what is VP? To find the VP, we simply apply nodal equation at node P. So to apply the nodal equation at node P, we have to choose one node as reference node. So we choose this node as reference node. Okay, so when this node acts as reference node, then we can write nodal equation as VP minus 0 by 8, VP minus 0 by 8 plus VP minus value of voltage of node M. Now what is the voltage at this node M? Okay, see, this positive potential of 10 volt source is directly connected to this node M. It means this positive potential 10 volt which will reach directly to this node M. So that's why this node M has potential plus 10 volt. Okay, so we can write VP minus 10 by 2. When I am writing VP minus 0 by 8, it means I am assuming direction of current like this. When I am writing VP minus 10 by 2, it means I am assuming direction of current like this. Or we can say that nodal analysis is simply a KCL equation. Okay, so now what is current at this node? This 2 ampere is leaving the node P. So for current leaving the node P, and this is also leaving and this is also leaving the node P. That's why sum of all these current must be equals to 0. That's why plus 2 is equals to 0. So on solving this we get VP minus 0 by 8 plus 4 BP minus 40 by 4 by 8. Okay, take LCM, is equals to minus 2 into, take this 8 here, minus 2 into 8. So on solving this we get VP 5P, this 40 with 8 to J 16. So on solving this we get VP is equals to 24 by 5. Okay, now what is VQ? We can easily write the equation of VQ. VQ minus 0 by 6 ohm, this is 6 ohm, plus VQ minus VM, that is 10 volt, by 10 by 4 ohm is equals to this 2 ohm is now entering the node Q. So we will write plus 2. Okay, so on solving this we get 4 VQ plus 6 VQ minus 60 is equal to 48. So on solving this get VQ is equals to the 6 and 4 10 by 108. Okay, because this 60 goes here, 60 plus 48 108. So here we get voltage of node Q is equals to 108 by 10. or we can write it as 54 by 5. So now VPQ is equals to VP minus VQ, that is equals to 24 by 5 minus 54 by 5, and that is equals to minus 35 by, that is equals to minus 6 volt. Okay, now here we can solve it like this and we get answer minus 6 volt. Now we will try to solve this question by using KCL method, KVL KCL. So here, to solve this question by KVL KCL, we have to assume currents. Okay, suppose here current, here in this branch current is A, and what is current here? See, this here enters the node, this A enters the node P, and this 2 ampere current leaves the node P. That's why current going through this 2 ohm resistor simply equals to A minus 2, because I have assumed the direction of current like this. Okay, now what is the current in this? Suppose current here is current B. Okay, and this current 2 ampere is entering this node, so total current here in this 6 ohm resistance is B plus 2. Okay, so after assuming this current, we can easily apply KVL and KCL now. Okay, now take loop 1. This is 1. So on applying, here we get 8A plus 2A minus 2 plus 10 is equals to 0. Okay, so we get A is equals to 8 plus 2, 10 minus 4 is equals to minus 6 by 10. Okay, now what is B? Now apply KVL in loop 2. This is loop 2. Here we can write 4B plus 6B plus 2 minus 10 is equals to 0. So we get 10B plus 12 is equals to 10. So we get B is equals to minus 2 by 10. Okay, we get A and B, that is equals to minus 6 by 10, and B is equals to minus 2 by 10. Now what is VPQ? Here it is visible to you or not? It is visible here. Okay, so VPQ is equals to, so see, if we have to find VPQ, then we have to move from P to Q. Now we can move from P to Q in 3 ways. We can move P to 4 ways. We can move P to Q from here. We can move through this path also. We can move through this path also. We cannot move through this path because here it is current source. So we take this path, okay, because this is short. So we get VPQ is equals to move from P to Q. So on moving from P to Q, we get VPQ is equals to A minus 2 into 2 plus 4 into B. And what is A? That is equals to minus 6 by 10. And what is B? That is equals to minus 2 by 10. So simply putting, we get that is equals to A is equals to 2 into minus 6 by 10 minus 2 plus 4 into minus 2 by 10. On solving this, we get 6 volt. Okay, so these are the two methods, and here we see how we can exactly apply the nodal and the KVL and KCL. Okay, I hope this question has cleared many your doubts and concepts. Now we move to another question.
If you got the knowledge and concepts from this video, then please like the video and subscribe the channel. You can give your views and ask any questions related to this topic in comment box. Also share this video with your friends because sharing is caring. Don't forget to press the bell icon to get the notification of my upcoming videos. Thank you.